critical temperature, critical pressure and eccentric factor of hydrocarbon gas mixtures. ये तीनों पैरामीटर काफी इंपॉर्टेंट होता है to find out the compressibility factor. So this chart. This is a pressure temperature diagram for hydrocarbon gas mixtures. So this is a vapor. This is a liquid vapor mixture. This is a liquid. So main properties of the gas involves are critical pressure, critical temperature and eccentric factor. Critical pressure is defined as the pressure at which liquefaction of gas is done at critical temperature, and critical temperature is defined as a temperature above which liquefaction of gas is not possible no matter how much pressure is increased, like above this point. It is to be noted that above critical point, gas cannot be converted into liquid like this. Above this, eccentric factor is a property of gas which measures the non-sphericity, that is concentricity of the molecules, centricities of the molecules, and due to this, boiling point gets elevated. Eccentric factor takes care of this. That means each gas component has a certain value of critical pressure, critical temperature, eccentric factor. To find out these properties of the gas mixture, mole fraction of each gas is multiplied with these properties and adding them up to get the property of the gas mixture. These are critical temperature, critical pressure and eccentric factor chart with all the hydrocarbon gas component, which can be referred for calculating these properties for the mixture. Now steps to be followed for calculating critical temperature, critical pressure and eccentric factor of hydrocarbon gas mixture. First of all, find out the mole fraction of each of the gas component. Multiply the mole fraction of each gas with its critical temperature and add them to get the critical temperature of the gas mixture. Similarly, multiply mole fraction of each gas with its critical pressure, add them up to get the critical pressure of the gas mixture. Multiply mole fraction of each gas with its eccentric factor and add them to get the eccentric factor of gas mixture. Now understanding with an example. Gas composition are given in percentage of volume. Calculate the critical temperature, critical pressure and eccentric factor for gas mixture. So these are the given: methane, ethylene, ethane, propylene, propane. Now column A is a gas composition and the summation is 100%. B is A divided by a mixture of gas. This will give the mole fraction, and critical temperature is given. Just multiply. So D will be, C is a critical temperature of the gas is given from the chart. D will be B into C is a critical temperature of the gas, and adding all them, this is a critical temperature of the mixture. Similarly, E is the critical pressure which is given from the chart. F will be B into E, which, and adding them up will give the critical pressure of the mixture, which is 45.533 is a mixture of for mixture, critical pressure for the mixture. G is eccentric factor is given from the chart. H will be B into G, which is a multiplication, and the summation of all these will give the eccentric factor of the mixture. So from the above calculation, critical temperature of gas mixture is 196.39 degree Kelvin. Critical pressure of gas mixture is 45.533 bar absolute, and eccentric factor of gas mixture is 0.013 constant. Understood how the critical temperature, critical pressure and eccentric factor of the gas mixture is calculated. So hope you like this. Thank you for watching.